Thanks everyone for coming, and I am super excited to be here. Obviously, it's been amazing watching the things so far, especially I was just really impressed with the things Heather was talking about, and we will obviously get into that here as well, but on a much less life and death sort of situation. Just as ways of introduction, my name's Brian. I have been working on understanding music now for roughly 18 years, which is a very long time. I was a musician living here in New York, and I ended up going to grad schools at MIT at the Media Lab. I graduated there in 2005 and started a company called the Echo Nest, which was sort of a B2B back-end music understanding company. The Echo Nest pretty much powers and still does power pretty much most music suggestions that you will have throughout your day if you listen to a Clear Channel radio station or Sirius XM or Spotify, which acquired the Echo Nest in 2014. You have sort of been under the thumb of our algorithms one way or another, which is something to think about, obviously. My background mostly is machine learning, information retrieval, and language processing. I'm going to try to raise this microphone just a little bit if I can. Okay, thanks very much. So I'm going to show you just some brief Philosophy 101. I'm sorry if this is a repeat for some of you, but this man right here, his name is Hillary Putnam. Hillary sadly passed away in March of this year. If you know Hillary, you know him for a saying, meaning just ain't in the head. Through a bunch of thought experiments, Hillary showed us that we sort of understand the meaning of things by the world around us, that not a single person, no one in this room, really can contain the sort of thought of something, the idea of something, the difference between two things, just in one person. It's got to be shared. We rely on some sort of organic description that sprouts up around us. That true meaning, really, it's sort of a group effort. I'm going to put this quote on the screen. I know not all of you can read it, so I'm going to read it out loud, and I'm sorry. This is from Hillary. The extension of a term is not fixed by a concept that the individual speaker has in his head, and this is true both because the extension is, in general, determined socially. There is division of linguistic labor as much as real labor. The extension of our terms depends upon the actual nature of the particular things that serve as paradigms, and this actual nature is not, in general, fully known to the speaker. He calls this semantic externalism. And everything I've seen happen in the field of machine learning, AI, music understanding, media understanding, Mike's stuff on Deep Dream, some of Heather's stuff, everything I've seen today, Rebecca's stuff as well, has gone towards this theory over the years. And over the past, almost 20 years, I've been looking at this stuff. It just keeps becoming true. And it's getting even more of it and more intense. We're all trying to give machines meaning, and we're sort of getting better at it. So throughout your day, you've been inundated with suggestions, either from a company like ours or some other place. Some of them are personalized to you, and some don't appear personalized, but they certainly are, just to a larger sample of you. For example, if you're on the subway on the way over and you saw an ad, obviously that subway ad does not know who you are, but it does know that you're someone that rides the subway. So I work now at a music company called Spotify. I'm their principal scientist, I think is my title. And I know I've spent a long time looking on computationally understanding music and listeners. In a place like Spotify, we've kicked the can of that semantic externalism down the road so far, it's almost unrecognizable. So the way all media companies work, all the ones that we compete with and the other ones that are out there in the world, Netflix, Pandora, Google, Amazon, YouTube, They're all making better and better suggestions through machine learning, IR, NLP, simple statistics. They learn about you and your activity, and they try to learn about the thing that they are trying to get you to do or see or curate. I'm not sure if you've been noticing, but these things have actually gotten a lot better over the past few years. It was actually only recently that most of our suggestions online were based on sort of incredibly crude and non-musical pieces of information about you and your tastes. This is Amazon. Actually, you might still see this on there, but if you go look at a record, it really will just recommend you other records by the same artist. Not a really informative recommendation or anything. This is my favorite one here. This is Apple's Genius, actually call it Genius. This is actually only a few years ago. They've gotten better since. But it's a 95-cent Senate report on pre-war intelligence, an audiobook, I guess, based on the fact that you listened to, or you owned, Baby One More Time by Britney Spears. Okay. Anyway, back to the present. So everything you see here on Spotify's homepage, on Netflix's homepage, and when you go to YouTube, it's because we aggregate data about listeners, about music, about artists, about podcasts and videos and movies. We then compute sort of simple things about correlations, songs that appear together in Spotify's billions of playlists, artists that have similar sort of sounds or acoustic properties, music editors that bring their meaning of genres and culture together to things like we have called like Rap Caviar, which is this huge popular playlist that Spotify has, for example. So a new feature, and this just came out, so I added it in just now. If you use Spotify and you're in a test set, which I believe is half of our user base right now, you can try something really cool and funny, I think. You can create a playlist with any title. You can use a word like, kittens, and I tried trees here in honor of Hillary. Actually, this is a feature written by the amazing Paul Lemire, if you know him. If you're in a test group, what happens is if you add no songs to it, it will show you recommended songs at the bottom. And what you're actually seeing here is sort of the semantic externalism of our millions of users trying to recommend things that match whatever you were trying to mean. I'm going to zoom in a bit on what Spotify users think trees are. Anyway. Maybe we have some work to do on that, multiple meanings of things. So in a more focused way, obviously, music recommendation. We have a feature now called Discover Weekly, which has become very popular. So what we know about you as a listener comes from the sort of aggregation of millions of people that curate and describe music for us. So we rely on this, obviously, for everything we do. This feature was actually built by a very small team within Spotify. More or less, they're factorizing the very large matrix of user to playlist to song item. And they're using a very common statistical NLP approach that sort of produces a series of embeddings of given groupings of like things, sort of like words within a sentence. So in the case of music, your listening is actually embedded in this sort of n-dimensional space alongside all of your peers and, of course, the entire world of music around you. What I actually focus on, and my favorite piece of art at Spotify to date, and the thing I'm actually most proud of, is this funny small thing called Fresh Finds. So what we wanted to do here is obviously, suggest things to people and recommend things to people. But actually we wanted to focus on stuff that no one has heard yet. And this is actually a very different use case than normal. Most recommendations are for popular things. And obviously as an independent musician myself, and many of our colleagues and peers are, it was sort of, well, how are we helping sort of the new artists of the future? So it follows that if there was no listeners of music of our own service, we would never be able to figure out to recommend it. So we get tens of thousands of new tracks a day, I think, something like that at Spotify. How else would we know about it? So instead of looking inwards, like we normally do for things like this, we started looking outwards. For a feature called Fresh Finds, we looked to the sort of external world of the internet. We actually crawl the entire web now, trying to read all about music whenever possible. If someone posts something on their blog or a news site or tweet or a Facebook post or something like that, we were trying to aggregate what people are talking about music outside of our service. So we hopefully are finding out about new things the way we all used to. We read things, we connect to our sort of, our cool older brother or sister, that friend that goes to too many shows, and we ask them in a very automated and roundabout way. This is an automated way to find these sort of tastemakers and promote music that has a really good chance of finding success. And we're updating it once a week with 150 new artists. It's my favorite part of this process, actually, and getting back to machine learning. was near the end of this process, we were about to launch it, we had some feedback that the music was too different within the playlist that we were making, that people wanted to have some sort of genre coherence. People were complaining about musical whiplash. So without batting an eye, and because it's 2016, someone on my team decided that they were going to build an acoustic genre classifier using unsupervised machine learning, because that's just what we do. We had an excellent, actually intern a couple of years ago, Sander Dieman, if you know him, he's now at Google, and he built a series of deep learning features, an eight-layer model here. And pretty much using unsupervised clustering and these deep features based purely on the audio, we built sort of a new music genre classifier. But that wasn't the best part. The best part was what we found. So speaking of unsupervised clustering and the bias inherent, the person on the team reported back to me, and this was a 22-year-old a Greek woman that works for me, reported back to me that here are the 5 types of new music in 2016, according to the computer. And that's it. That's all we had. And I don't know if you notice anything missing right now. There is female vocal pop. There is electronic music. There's hip hop and R&B, which we put in the same cluster. There's guitars, and then of course my favorite, other. Notice there's no male vocal pop in here, which I thought I'm letting it go, and I think this is a current, accurate state of new music in the world right now. But I'm going to look into that at some point. Obviously, my favorite is other. We remarketed that one as, we called it a cyclone instead, because it sounded a lot better. Other, Fresh Finds Other was not, we have a pretty big marketing team at Spotify now. It's been fun to watch. And we actually have a full-time staff for curators here as well. Obviously, there's humans involved in this loop, and we do pay someone now to go through this list of mostly 20-minute-long sine waves and things like that and see what the kids are listening to, and it's been pretty great. So I mean, every week, just imagine just in the real world here, this is not a research project, this is not an art piece, this is a product to a very large consumer company that is happening all the time, using all of these sort of pieces of biased and unbiased machine learning that are just happening without anyone thinking about it. I found this amazing artist, by the way. I just had to put this in here. He was on Cyclone this week. Food Man. I'm just going to play some of it because it's the last talk and it's really beautiful. So this is Other, by the way, just so you know. So just to speak a little bit more to the sort of the power of this stuff and what's actually happening with it, many of these artists that show up on things like Discover Weekly and Fresh Finds are waking up in the morning to just like tons of new listeners. Some of them had about a dozen listeners and they've got millions or hundreds of thousands, and it's all because of some algorithm that sort of figured it out and chose them. We actually have them come in to talk to us directly because they're usually very flummoxed. They don't really understand what happened or why, or if they had to talk to someone or they had to get noticed or do other things. But usually it's really this sort of, in our case, as unbiased as possible, this machine learning algorithm. This is my vote for a most postmodern tweet of 2016. I get a lot of these. This is from a band called Sure Sure. They were on Fresh Finds a few weeks ago. They are now taking off. They've got over 1 million streams now. It's going amazing for them, and it's really because of this. They call it the algorithm. They have no idea or why, or they looked me up on the internet and they found it and they sent me this tweet. So I asked them to thank semantic externalism, not me. Okay, so moving on from analysis, I do want to talk about synthesis because it's actually very interesting. A lot of stuff has been going on in the world around not just understanding music, but understanding music enough to make more of it. I love thinking about synthesis around now because something neat or annoying is about to happen. We just talked about knowing more about the meaning of stuff helps it get better, but it's also going to work in the same way for synthesis. The art will closely follow, that's the way I've seen it, once we sort of lock down how the technology part, the consumer part works. So if not already, many of you will soon hear the sort of dulcet tones of robot music, made by an algorithm. It'll start appearing in your Facebook feeds and your parents will send you links to it and they'll ask you, what does this mean? Are you going to be out of a job? There'll be a lot of think pieces and things like that. Don't worry about it. Mike over here, worked on the sort of dog generator, as I like to call it, and it followed a very similar path. Last year, all of a sudden, out of nowhere, there were these pictures that just came out of nowhere, and it sort of took over. And it's just important to note that this was a few years after we started doing really good in ImageNet, meaning the use case, got done, the things we were using it for, but then the art happened a few years later, once we sort of figured out how the systems were working. This is gonna happen the same way for music, absolutely. There'll be some hot takes, again, will robot music put artists out of business? 11 ways deep learning has killed music. This will just happen over and over again. So my advice to you is to ignore it. But it's because it's already actually begun. There's actually a bunch of startups. This is a Juke Deck. They actually claim to use deep learning. I'm not really sure how, but they will create a bed for your video for you. You type in, what kind of music you want to give it a mood and tell it how long to make it, and what kind of feeling it has or genre. And this could either be them nicely putting stems together, or it could be something more interesting. It doesn't really matter right now. The point is, it's automatic. My good friend Mike Casey at Dartmouth, I just saw this on the news the other day, so I thought I'd put it on here. Dartmouth contest shows computers aren't such good poets, it says, but there's Mike on the laptop there in the corner. They're working, Dartmouth's the team, they're working a lot on this stuff. I also have a good friend Douglas at Google. He's got a whole new team working with the Google Brain team on sort of generating music and arts. I wish Doug very well. He's gonna do amazing. He's an amazing person. I do work because his favorite artist is like late period Wilco, so I'm a bit nervous about his music taste and how the scientist biases the output. It's not gonna go well for Doug. I don't know, we'll see. Do you really want Google composing music is all I'm saying right now. Anyway, of course, though, we've had automatic music for years. This is not a new thing, and I just want to couch us all in the real context. We've had Band in the Box.
Now our goal here
Love
is
this
now
video.
we want the vibes to double the melody, and by doubling the melody, we can use one of these channels which is devoted to doubling the melody. We want the vibes to double the melody, so we'll set this to B. Now this would determine what octave we want it to occur in. So let's update that. So you can hear the vibes now doubling the melody. And
So anyway,
we want the
yes.
vibes to double the
Just
melody
imagine this,
right
but in
the same
Google.com.
octave.
That's what's going to
So
happen.
we can leave this setting at 0.
We've of course had the SID chip. I don't know if any of you are older computer people. Commodore 64, the first mass market microprocessor that only output sound. By the way, that's so it was actually a computer that was you wrote code for it to generate this beautiful music. This is Martin Galway, a composer that wrote code for this, 1982, I believe. And we've had C sound and we've had wind chimes. Obviously, we've had music being made by systems for a really long time. This is nothing new for anybody, right? We've had composers encoding sort of pleasing combinations of things into a rule system and then synthesizing it back since I believe 1400 BC. And any modern musician obviously is taking advantage of whatever technology they have available to them. So again, I'm just trying to tamp down the oncoming onslaught of hot takes just slightly if I can, although I don't think it's going to work. And there's also an entire industry, which is really interesting to watch, around just sort of music collaboration and sort of shipping music beyond the bits, the audio, meaning in the future, a future music service, you could be able to play with the audio. You can turn down parts of it. You could speed it up and slow it down much more than you can now. And I like watching this because it really ties in the sort of automated part with the composer's intent part. And one thing I got really into actually in the process of preparing for this talk is something called Vocaloid. I don't know if anyone here knows what Vocaloid is. It's really, to me, if you're sort of a historian of what's going to happen, Vocaloid is pretty much what we need to look towards. It's a culture sort of well beforehand, already understanding and dealing with robot music. It's a piece of software that synthesizes voice, more or less. So you have music synthesizers that can do a trumpet sound or piano sound. This one does a human voice. And you install it into your Logic Pro or whatever, and you actually can synthesize someone saying something and then singing it. And they sort of sing in a lifelike manner, although it's not that lifelike. But lucky for them, our current style of singing in America in 2016 has become easier to parameterize, right? I mean... Vocaloid is actually also the name of the genre, which is really interesting, and that's what I'm sort of looking forward to. Will we have like a deep music genre in a couple of years? Will people actually start doing what they do now on the Vocaloid wiki, which I've read almost every page about 3 a.m. last night on? It's really something, because people, obviously they get into the sort of the anime characters that represent each voice, but also the technology within it. They are here fighting sort of in a very strange way about a potential Vocaloid 5. We're up to 4 right now. Vocaloid 5 may or may not have vocal fry, and they sort of, the concept of, when you talk like that, I'm not gonna do it, but then which singer is going to own vocal fry and who's going to premiere it, and like these are all of course made up singers, they're anime characters, so it's been really great to watch the sort of transfer of culture onto the technology. So I mean, raw technology was never preventing us from making this sort of next leap of new music. Obviously, Kate Bush here with the Fairlights in '81 here. A Fairlight was one of our earliest digital workstations for music. We've had those in claviers, Lindrums, all sorts of things that could help us make any music we can think of. If we are careful enough, we can arrange the ones and zeros by hand, and then for an infinite amount of time and make any sound that we can hear. This has been possible to us since at least the 70s, right? So nothing really is a step change in how we perceive music. The moment in time a computer processor can render that back out to a speaker, that was the moment that all of a sudden anything became possible. And that was many 30, 40 years ago. So what will be new though, and just like we talked about last with the understanding of music, is the scale. So we'll reach for the world to tell us about music and make it for us. Everything I just showed was something that only required one composer. It was all internal. It was one notion of meaning. It was internal to like a single frame of reference. The Martin Galway, who wrote that Whizball song, that was one person encoding his thoughts of music into one machine. But we'll want there to be some sort of hazy, undefined black box, something more of understanding that we'll be able to know not just the things about music that was in the programmer's brain, but everything, all the music in the world. Maybe. So one thing that certainly happened in the past few years is that we can now waste a lot more GPU cycles and CPU cycles than ever before on a convolutional neural network. That has definitely happened. I found this picture of, this is a Tomb Raider, I think it's Lara Croft over the years, and I mapped it against our accuracy in ImageNet here, which starts in 2010. And you'll see here that I don't think anyone could have predicted the sort of that our national need to somehow render these video game breasts would be the initial economic driver for uncanny artificial intelligence, right? I mean, this whole strange, like, we want to make things more real or unreal or whatever's going on up there, I can't really explain it, can impact how we're actually doing on photo sharing and understanding pictures, face recognition, all sorts of other things. If you don't know, what's happening in the world of machine learning right now is that companies like NVIDIA or AMD who make these cards are pushing hard to use the same technology that makes whatever's going on above to really help do the things on the bottom as well. So you call this deep learning. We can make these models bigger. We can increase the scope of the world we learn from. But I hope this room knows that none of this is actually new, right? I mean, the early deep learning papers were all in the 80s. They were possible. We were able to run very small versions of them. But just sort of like we have the Church-Turing thesis, which tells us that something once computable will always be computable no matter what the actual technology is. We sort of have that as well here for the possibilities. It's obviously a heck of a lot easier now. So I think one of the reasons I was invited up here was that many, many years ago, I actually did some of this, well before in our new world that we're in now. I wrote very intensely slow convolutional neural network algorithms. I convinced my advisor at MIT to buy me these 12 computers that maybe, if put all together, could be slightly faster than my iPhone is now. Things have changed very drastically. And what I was making were things like this. This is a piece I did back in 2003, a very long time ago, called Eigenradio. It actually would listen to about 20 radio stations at once. I actually had tuners plugged into it. And it tried to compose what it thought music sounded like by listening to the whole world of music at the time defined by those 20 stations. The idea for this was to be computer music, not music made by a computer because everything is, but actually music what a computer thinks about music, music for computers. Mostly sounds like this. It's really good. I later changed the algorithm. For a while, I was studying, as part of my dissertation, if a computer could detect if a song was about Christmas or not. And this was a big piece of work that I was trying to figure out. This is an important thing, actually. And to be honest, at Spotify now, it's one of our biggest issues. We don't want to put holiday music in another stream, for example. People don't tend to like it. So the thought experiment was, imagine someone doesn't know about Christmas, and then you play them a bunch of Christmas songs. Will they see the connection? Is there something innately Christmas about Christmas music? Is it like that sort of bell thing, the sleigh bells, or the wide open, like chromatic melodies, or there's all sorts of stuff in Christmas songs. But my theory was, if we can synthesize Christmas music from analysis of all the Christmas music I could find, if people thought that synthesis sounded like Christmas music, then we've cracked the code, we've understood Christmas music, right? And that was what I was doing. Sounds like this. I know it's May, but is anyone feeling festive right now? Anyway, with Single Christmas, I was obviously bound by data. I didn't know I could have queried, if I could have a query database of millions of songs, if it was possible even then. This was 2004. There was no Spotify or Econest or anything like that. And there was no real answer of what is Christmas music or not. We're getting there now. And there was, even if I could have all that, there was no computer that could do it. There was no processing power at the time even available to really pull that off. And that's going to change. And so we've seen how taking advantage of this sort of confluence of tractable processing and things combined with having the world's thoughts encoded online has changed how we're interacting with music. And it's about to happen with how music is made as well. And I'm really excited about the future because we'll be able to ask a lot better questions. So thanks very much.